Here is a comparison of 4 USB dongles with the RTL SDR software. This one is the FC0013 tuner. Here is the E4000 tuner with the Linrad in the linearity gain setting mode. This is also the E4000 tuner with an identical doggle, but here it is running with the Osmocom original gain setting mode. And here we have the R820T dongle. Here on the right hand side is a fifth instance of Linrad. It is running on the loudspeaker output from the other 4 Linrad instances, but the loudspeaker is turned down in all of them, so there is no signal here. Let's turn up the sound of the FC0013. Something like that. We can listen to it. I just turn up the knob on the loudspeaker in front of me. Signal to noise, the bandwidth is 1 kilohertz from here to here. Signal to noise is about 62 minus 56. That is 6 decibels. And it's S plus N over N. 6 decibels for the 0013. So, and here there is no interfering signal. I'll switch on an interference source. It's FM modulated signals, 100 kilohertz lower in frequency. Here we go. And you can see nothing on the screen except, of course, the interferer signal here. But it doesn't affect the audio spectrum. And if you listen, you cannot hear when I switch it on or off. The interferer, when running, is at minus 80 dBm, while the signal is at minus 130. So the amplitude difference is 50 decibels. And it means a 50 decibel stronger signal doesn't disturb when it's 100 kilohertz away. And that's for the FC0013. Let's turn that off and turn on this one. Oops, I have to click on the signal also and tune it. Oops. Tune into it. Seems I have put the BFO on the wrong side here. To make it equal to the other ones. And we need a little bit more to see on the S meter. So the E4000 dongle with Linrad in linearity mode goes from about 61.5 to 61.5 minus 54. That's 7.5 dB. 1.5 dB better than the FC0013 dongle. Not a big difference, just very small. Let's see what the interferer is doing. absolutely nothing. So the same, an identical tuner, but running the Osmocom original gain distribution gives this result. It goes from, just have to wait and get the statistics. (64.5) minus 56.5. 64.5 minus 56.5 is 8.5, 8.1 dB. That cannot be right. Stupid computers or stupid operators. 64.5, 64.5 minus 56.5, 56.5 equals 8 dB. So it seems to be half a dB more sensitive than Linrad in linearity mode. I don't remember, but you can find it on my homepage. Probably this is expected. Linearity mode is for optimum linearity, not optimum sensitivity. And let's see what the strong signal is doing. It's doing nothing. So there is one more to look at here. The R820 from 65 to 56. That's 9 decibels. This is the most sensitive of the dongles, and it's about 3 decibels more sensitive than the FC0013, which we have here. And you can see it also here in the baseband graph if you look at it. Here it's a little bit better than here. And let's listen to the interferer. And here we can actually see a small effect. You can see the noise floor in this waterfall, or you can see the noise floor in the waterfall here. And you can also see it in the S-meter graph. It's about half a decibel, probably reciprocal mixing. The higher sensitivity makes it a little bit more sensitive to that. Now let's change the frequency of the interference signal. I step it downwards. This is the first point where something happens, and we can see it happen in the Osmocom code. I will switch over to that one. So it's a problem, and it's the mirror image. As you can see, there is no mirror image in this window here. Absolutely nothing. The reason is not that the gain distribution is different from here to here. The reason that the mirror image is not present is that this instance of Linrad is calibrated, while this one is uncalibrated. Calibration removes the mirror image. So, let's continue stepping the frequency downwards. Now, when being outside the passband, the signal, the interferer is 50 decibels. I increased the level to 70 decibels above the desired signal. 10, 20. Now we can see here is the alias signal, and here, and here. But in the R820 there is something more, another interference, and something very ugly, I don't know what it is, down here. Stepping the frequency downwards. And you can see on the R820, now I happen to change the tuning frequency. I will go back and fix that. You can see there are interferences. This is the alias, but there are other things here. Continuing in frequency downwards. There are many odd phenomena in this tuner, but it doesn't seem to harm the sensitivity much. So, the next step is to increase the level again with another 20 dB, like that, and stepping around. I'm now at 137.2, stepping upwards. Note the difference between the two E4000 dongles, here and here. We'll come back to that later. The R820 has a problem here. I don't know exactly the mechanism. Probably it's a mirror image that is now saturating something. So in a quite wide frequency range, it's from, I step back, It starts here, 139.8, 9, 140, 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9, 141, 2, 3, 4, 5, 6, 7, 8, 9, 142. You didn't see much in the E4000 dongles until now. Here it starts to, it's the alias frequency that starts to come up. And we can see that also in the FC0013. And soon we get into the 2 megahertz bandwidth, so everything saturates at 142.9. Stepping downwards. So the a little bit more sensitive 820T has a problem with signals about half a megahertz lower in frequency. Now I increase the signal level again by 10 dB, like that. It is now minus 20 dBm on the interferer, but it is minus 130 on the signal, on the desired signal. And if you look, I step the frequency of the interferer to come on the signal in the E4000 dongle here. Let's listen to it. So it's not useful. In linearity mode it's different. We can see the interference, but it's much weaker. And we can also turn down the gain a little bit. And the relation between the signal and interference becomes a little bit more favorable. It's just a very small difference. Turning down the gain does not help at all in the original gain distribution. So let's move the signal a little bit on the side and switch on one more signal generator. Now there is a second signal on 134.6, and I tune the frequency a little bit. And we hear nothing. Then turn down the gain. Sorry, I'm listening on the wrong spot. There is some interference, but we can hear the signal. So here it doesn't work. We need the linearity mode to be able to avoid this third order intermodulation. In the R820, let's listen to that. So it is very good in terms of third order modulation. It's about the same as the E4000 dongle in linearity mode. Or even better. But it has the problem 500 megahertz below. It needs a filter. The gain step one would have liked to have is not available here. Intermodulation is gone, but the signal is a little bit too close to the noise floor. Now I've switched off the second generator, and there is only the FM modulated interferer in place. It is at minus 40 dBm, which is 90 decibels above the desired signal. The frequency is 140, and I step it up in steps of 100 kilohertz. You can see that the R820 is completely destroyed, while the other three are okay. And here the FC0013 doesn't work anymore. It's 140.6. .5, .4 is okay. And in this frequency range it's now 141.4. Up to here the E4000 are okay. It's now 141.5. And to be honest, we should have the same gain everywhere, which makes the difference much smaller. So go down. It should be clear that the dongles differ. It's not so obvious which one to prefer in different situations. It depends on the RF environment and whether you have a filter in front of the dongle or not.